Looking forward to all of you, right? Yeah. So today we are very happy to have Dr. Mook Bangalore to give us talk here in coffee hour. But as always, before that, we have some pretty nice good news to announce right before I introduce you. Here. All right. So are you ready for the good news? We'll hear that from here. So we have three pieces. Good news. The first one is Alan Harrington had his first publication accepted this week in Energy Research and People Class. For with Dr. Jim Barr. And the title is Anatomy of Inscrutability of the Unconventional Oil and Gas Development in the Waterhouse Nexus in Pennsylvania. All right, that's for this title here. Our second, again, good news is Professor Jim Barker was named 2025 IEE Fellow. I think you all. Congratulations. And also the third one, Professor Louisa Holmes had a couple of articles, for that one published this month, including one about cannabis, about tenders and medical advice in cannabis, and also an article titled Hiding Access to Quality Parks, a case study examining park serve and objective park assessment in an under-resourced community in city and health. So, yeah. No articles in 1 month. So, all right, that's good news. Any other news that people want to share? Good. No, now to you, Dr. Mook Bangalore is an assistant professor in the School of Public Policy at Pennsylvania State University. And his research focuses on the relationship between environment and development, and explores how households across the global south are affected by environmental change. And previously, he was a postdoc researcher at UC Santa Barbara and also Princeton University. Cool. And he received his master's degree and PhD from the London School of Economics and Political Science, and has a BS degree from Rutgers University. He also loves watching sports and cooking. All right, and sometimes at the same time. Oh, that's nice. All right, that's well, Dr. Thank you. Yeah. All right.
Yeah, thanks so much for the kind introduction, and I'm glad that you had three pieces of good news, because the bad news you got to listen to me for the next 45 minutes. I'll be talking about flooding, particularly about understanding the impacts of flooding in a low and middle income context. And I feel like geographers probably find or more interested in some of these questions, especially in different geographies. When I go to different conferences and seminars in the past, a lot of the work focuses on the US and on Western Europe, but I'm trying to push the agenda a little bit to talk about how we understand and measure some of these impacts in a low and middle context. And I did my PhD in the geography department. Jen and I were at the LSE back when I didn't have gray hairs. Back when Jen still doesn't have any gray hairs, but so I feel really comfortable hanging out with all of y'all. When I came here for my job talk a couple of years ago, I was staying up to the Walker building, and this dingy building felt just like home in my old apartment, geography. So even though I'm trained more economics, if you have any questions, anytime, just feel free to raise your hand or throw something at me, and we just have a conversation for the next 45 minutes to an hour. So I'm gonna frame the talk around 4-ish questions, and we'll see how many of these questions I actually address. Maybe you might leave this talk asking more questions and getting answers. I think that's kind of part of the life of being a geographer. And then I'll end with a couple of closing thoughts about some of the things I've learned over the past 5-10 years, some things about how I think it's important for us to push the agenda a little bit methodologically also the uncovered thing more than the past floods in the global south. So the first question that I am asking in today's presentation is what the hell is a flood? And what do we mean when people say that they're flooded or they're exposed to flooding? Like, what does this actually like mean in our minds? So the first flood that I know is a Irish soccer player. His name is Willow Flood. He played for Dundee United. He was to be honest, pretty mediocre soccer player, but he's the first flood that I remember. But another way to figure out what floods are is just like going on Merriam-Webster and just typing up, okay, what is a flood? And typically the number one definition here is a rising, hey Jonathan, come on in. A rising and overflowing body of water, especially on the normally dry land. So like typically a textbook definition of what a flood is. You'll find more definitions from the scientific literature, and for example, NASA, what they say is flooding occurs, and basically put your like glasses on, like your top hat on when you say this. Flooding occurs when water accumulates faster than can be absorbed or transported by the underlying surface, and is most commonly caused by prolonged or heavy rainfall. Another definition of what a flood is. And in terms of the causes, it can be caused by heavy rainfall, rapid snowmelt, ice jams on rivers, storm surge, or structural failure, for example, through dams. So another definition of what a flood is. I'm going to propose another working definition for us to try to fix our minds on throughout the course of the presentation. And this working definition is going to have three components. So the first component is that it's more water than normal conditions. So thinking about both the Merriam-Webster's definition and also the NASA definition, it's kind of what we generally understand. There's more water than usual is, so increase in quantity of water. And just think of a situation where a road is flooded. Usually it's not flooded, but in this case, it is. And the second concept is going to be in a place that is undesirable to humans. So if there's a lot of water, but there's no people around, then probably that's not what we would call as a flood. It's just water in an area where no people are. But when the water is in a place that we're in, that's when people think that it's more likely to be a flood. Think about the location. And then the third is that this water has some disruption to socioeconomic activity and or some sort of impact on human well-being. So it has some sort of cost. And I think of a situation like this. This is a flood in an urban area where it's totally just log jamming, all traffic. People can't get to work. There's probably health impacts in terms of the water supply. There's all these types of costs. But importantly, some of these costs can actually be positive. For example, if I'm growing rice, and rice is a crop that uses a lot of flooding. If my agricultural field were flooded and I'm growing rice, it can actually benefit me. So think about where these things are happening, who they're happening to, and how much water is actually occurring. So again, quantity, cost, and location. And all these three conditions are super important to understand what it is when you hear the word flood. And I encourage you to think about this in your research or in your discourse, like as you go to other seminars where people use the word flood or say they're studying the impacts of the floods. Maybe ask a few more questions about what they mean by that and how they're measuring it. So I feel like we oftentimes throw out this word flooding, and it doesn't always have the same understanding in my mind as it does, for example, in your own. Okay, so that was the first question. I think pretty easy, pretty straightforward. The second question I'm going to ask is, why do we care about flooding impacts in lower and middle income countries? And one of the motivations that I think about with this situation is the risk is really growing a lot in the global south. So this is a figure from Talman et al. And the colors that are in the dark indicate increasing proportion of the population exposed to flooding risk. So we see a lot of increase of exposure in sub-Saharan Africa, in South Asia, and it seems to be more pronounced in the global south more generally. I can show you 2 or 3 other papers showing the same thing or even worse. But just I'm going to show you a lot of maps today, so I didn't want to show you more than necessary. And the way I like thinking about this is through some work that I was doing when I was a little back a couple of years ago. And the way that we thought about this is to first take a step back and think about the context that people are living in some of these areas. So this is a village in Andhra Pradesh, and this is a paper by the Anirudh Krishna, who talked about the impacts of understanding long-term flows of poverty and how natural risks like floods impacts those long-term flows. So what he did was he studied a number of villages in Andhra Pradesh, and he looked at people's poverty status over time. So he would study them from year to year and try to understand what's going on in their lives. And I know there's many definitions of poverty, but for this one, he was just thinking of a monetary definition of if you earn a certain amount of money, then you're classified as non-poor. If you earn less than that, then you would be classified as poor. And what he found is that every single year, there is this churning process where about 14% of the households were able to move from a categorization of being poor to a categorization of being not poor. So we think that this is probably a really good thing. If we just focus on this, then I think the storyline is really great, and we're increasing people's living standards in sort of close. One of the problems is that every single year, about 12% of the households that he sampled did the opposite, or they used to be considered not poor, but then they became poor over the same exact time period. So what's really important is for us to consider what are the net flows, what are also the gross flows. For example, if we had just a net flow of 2%, you might cite this in a paper and say poverty is decreasing by 2% every year. But they really missed out on this big churn of people escaping poverty, and there's also a big churn of people going into poverty. And in both of these cases, what Krishna finds is that weather events, flooding, drought are big reasons why people fall into poverty, but also why they stay in these types of poor conditions. So I think this is really important for us to think about how flooding events impact people's situations on an annual basis, and how does it impact their ability to increase their asset base and grow over time, and what are the constraints that people face on a year-to-year basis. And there's 3 other reasons why I think that it's important to think about flooding impacts in a global south context. And I'll go over 3 components of the risk framework. So some of y'all might be familiar with the risk framework when you think about exposure, where is somebody actually living in an area that's exposed to a flood or a drought. And think about the vulnerability. So for a given level of exposure, how much does that person lose? And then think about their ability to adapt. So if, say, someone is affected by a flood, how quickly do they respond? How much support do they have to try to get to their initial situation? And I'll be talking about these 3 components: exposure, vulnerability, and then the ability to adapt or respond. And on the exposure side, I'll just give a case of Nigeria. We'll be talking a lot about Nigeria over the course of today's presentation. But what we're finding is that poor people are much more likely to be exposed to these types of extreme weather events, whether it's a flood, whether it's a drought, or whether it's extreme heat. And in the map I presented earlier, with the settlement map of all the countries of the globe, that was more of a country level. So poor countries generally are more exposed to flood, but also within poor countries, which is this analysis, poor people within poor countries are also more exposed than their non-poor counterparts. And it's just a figure illustrating this with some data from the DHS, Demographic and Health Surveys, where the poorer a household is, the more likely they live in areas that are exposed to extreme heat. So on the exposure side, this is just one case study in Nigeria, but I think that this is pretty much replicable in a lot of other contexts. So think about where people are living within a particular country. The second, on the vulnerability side, something that we find in the literature is that almost every single event where folks have studied about what the impacts were, people who are poor tend to lose a larger share of their income and their assets compared to non-poor people. So in these cases, there's a couple of studies on floods from Bangladesh. There's a couple studies, one in Honduras, one in Mumbai. And in each one of these cases, the yellow bar, which shows the share of losses for poor people, is always higher than the share of losses for non-poor people. And this doesn't mean that non-poor people don't experience significant losses, they do. And in some cases, their losses are probably higher in total monetary value compared to poor people. But if we're thinking about the share of how much people lose, it's typically a story where poor people will lose a lot more. And why is this? So there's a couple of reasons. And one is that for someone who's considered non-poor, a lot of their assets are in financial form. So most of my assets are not in my house or in my office. It's actually not much in my office. I probably came to my office the other day and asked me where all my diplomas were. And I just showed him a picture of the New York Jets, my favorite football team.
Oh, you poor you.
Yeah. Phones talk about poverty. But most of my savings, and some did a PhD for 6 years, just did a postdoc. It's not very substantial, but most of my savings are in a bank account. So if there's blood in say college, I also have like most of my money, right? Compared to someone who lives in another context where a lot of their asset base are physical, livestock or crops or other types of assets that are really vulnerable to a flood or a storm or a drought. So one reason why this is happening. Another reason why is this is my house in State College. I'm just kidding. But if you live in a house like this, you're probably not going to be affected by a flood or a drought. But if your housing looks like this, then you're probably going to experience a lot more impacts in terms of your houses. Think about what people own, where people live, and why this determines some of your flooding effects. Okay, so then the third component of the risk framework on the ability to adapt is that we find that poor people spend a lot more money out of pocket on their health expenditure. So this is just a plot, a scatter plot of country level data, where on the y-axis is the share of health expenditure that's out of pocket, and on the x-axis is just the GDP per capita. So you find poorer countries bunched up here on the left, and richer countries here up on the right. And people in poorer countries just have to spend a lot more money on health shocks and pay for it out of them. And the WHO estimates that 100 million people every year fall into poverty because of health expenses. So think about these flows of poverty that Krishna was talking about in Andhra Pradesh are happening all the time, and they're happening because we don't have safety nets, which makes people more vulnerable to these types of shocks. One more figure. So this is just an example in Indonesia about comparing poor people and non-poor people, about how much support they get from social protection schemes. So poor people get about 50 cents per day in terms of transfers from the government. Non-poor people get about $2 per day. Non-poor people also have more of their savings in the bank, so it makes them more able to respond when the flooding event occurs. Okay, so we've covered the first two questions, and I haven't heard any questions from the audience, so I'm going to pause real quick and just see if anybody has any clarifying questions or wants to make more fun of the chest. Before I move on to the more substantive part of the talk. Yes.
How do you define the poor people and non-poor people?
Yeah, so a lot of the definitions that I've been using have been through monetary definitions using people's consumption. So if someone, say, spends less than $2 per day, typically they're considered as poor in a lot of these analyses. And if they spend, say, more than $2 per day, then they're considered non-poor. It's not an amazing definition because if someone spends $2.01 every day, I think they're still like, in a case where they don't have a lot of needs. So think about like other definitions of multidimensional ways of measuring poverty, but the ones that I've used for now are monetary. I think a lot of these patterns still hold using other dimensions of poverty. Yeah. Okay, so now I'll start to talk about how we measure flood exposure in a low middle income country, and how do we understand some of their impacts. And on the exposure side, I'll be showing you probably like 20 maps over the course of the next 20 minutes. And I love maps. I mean, we're all here, so we love maps. It'll be okay. And I'm going to show 2 examples of floods that occurred in Nigeria. One flood that occurred in 2012, and one flood that occurred in 2022. So the first flood that occurred in 2012 was a really, really severe flood that was the worst extreme event to occur in the country in 50 years. Over $17 billion were the economic damage figures. Over 400 people died, but I think it's a super underestimate of the actual impacts on the ground. Millions of people were displaced. It was really a key event, and I'll be showing some results from a paper with my colleague Tom McDermott, who's based in Ireland. So, what we did in this paper is try to figure out how do you measure this event, and we found 8 different approaches to measuring this event, and I'm going to show you all 8 just for fun. So, the first way to measure this event was a flood extent that was published in a paper by Enzaribe et al. In 2014. And the areas that are in the blue are areas that are flooded according to this paper. And when I was working at the World Bank, a Nigerian official was talking, and he basically presented this map as areas affected by flood in Nigeria in 2012. And for those of you who are looking for some spatial context, Nigeria is about twice the size of California and about like 33% larger than Texas. So what this is really showing is like essentially think of the entire country of Texas being considered flooded, which to me asks more questions than it actually answers. So this is like one first way to measure the flood from this paper, and this is what the flood extent looks like. Clearly, the flood impacts are not going to be homogeneous within this entire area that's the size of 2 Californias. So, what do we do next? We look at other approaches. So, the Dartmouth Flood Observatory is probably one of the most commonly cited and used data sets to measure floods. And I looked at their database, and they provided this flood extent in the light blue. So they had one large area here to the east, one polygon in the middle, one in the northwest, and a couple in the southeast. And again, think of the size. So like this polygon over here is the size of EDM, where the entire polygon would be considered flooded. So if we're looking to the authoritative source of at least that time of flood databases, this is what the Dartmouth Flood Observatory tells us about what happened in this paper. Okay, next. This is data from VIIRS. It's a satellite that NASA runs, and I was able to download the data and put together this flood extent using satellite imagery. And the satellite imagery is at a much higher resolution scale So we get a very different estimate of what areas were flooded if we use the VIIRS data. And the VIIRS data basically takes pictures of the ground, and where there is water or where there is flood, it will be coded as a flooded pixel. So it's able to put all the flooded pixels together, and the flooding extent looks like this. So clearly, it kind of looks like a Jackson Pollock painting compared to something that was, a bunch of huge polygons. So these are three data sets to measure the same exact event in the same exact year. But I'm not going to stop there. So I also was able to collect data from what's known as the post-disaster needs assessment. So the World Bank runs these post-disaster needs assessments in areas affected by flood and drought, where they work with government partners to understand what the impacts of the particular event was and quantify which areas were affected. So I was able to get the data, and the areas in green are the areas that the post-disaster needs assessment considers flooded. And this uses a different satellite than the VIIRS to identify the flood extent. And the correlation is much better with this green PDA data compared to the VIIRS, but it's still very different from the other data. And then we got one more. So we got the Global Flood Database, which is a database run by Telman, who I mentioned before. And in their database, they only include flooding along the Benue River on the east, and a little bit of flooding in the northwest. So still a little bit different than what the other databases are telling us. So I think like part of this paper is to make the case that if you're running an analysis on flooding, maybe it's important to think about what are the different approaches to measuring it. Because, for example, I could have just taken one of these. For example, I could have just taken this and stopped there, and then run an analysis using data. And I would probably find different results if I had used, say, the PDA data. So I encourage all of you to think about what are the types of data that you're using to measure floods? What are some of their pros and cons? What are some aspects of the methodology? And what's most appropriate for your use case? Because it's really important for us to figure this out, especially in a world of publication bias, where you can imagine somebody running regressions on flood extents until they get significant results, and only presenting the significant results in the paper. That's probably not the best way to do science. So I think consider multiple approaches for measuring flood exposure. So I'm going to show you three more of the same exact event, but this time using people data about what people in household surveys are telling us about whether or not we were flooded. So the survey data that we use in this paper is from the General Household Survey Panel in Nigeria. And what they ask is, they ask household to report whether or not they experienced a harvest failure from a flood. So this definition is going to be very agricultural, because if you live in an urban area, you may be affected by a flood, but you don't have a harvest. So you probably would say no to this question. So think about it more of an agricultural flood. And these are the areas with darker reds that show more areas exposed to the flood. Then people were asked another question later on in the survey about whether they lost any crop due to the flood. And I would expect if someone had a harvest failure, they probably lost crops. But the correlation is actually not 1-to-1. So households who lost crops due to flood are not always the same households who say that they have a harvest failure. So you can think about measurement error and how people are being asked questions in these surveys. And also the way we ask surveys, we typically have like hundreds of pages to ask people. And who wants to sit with a surveyor for 4 or 5 hours to go through all these different questions? Maybe we want to have more targeted questionnaires for flooding, something smaller or shorter, where we get more accurate responses. These are all, getting more questions to ask. Then communities themselves are asked to experience flood. And again, we see a different distribution of the communities that say that there was a flood in their community. So in the first two data sets, you're asking people, you're asking households. In the third data set, you ask community leaders to report when there was a flood. And again, you find a little bit of a different distribution when it comes to the same exact flood in the same exact survey. So there's a lot of uncertainty about what these measures actually mean. And I ran a correlation of the 8 different metrics that I showed you today, the 5 that are spatial and 3 from the survey. And the correlation is very close to 0. Highest is about 0.5 between 2 spatial data sets, but overall, these surveys, these flood exposures estimates are wildly uncorrelated, even for the same exact event in the same exact question. That's maybe the first key takeaway message from this talk. The second is that when you run a regression, you'll also find very different estimates. So this is the impact of the flood on agricultural value for farmers. And depending on which data set you use, you get very different results. I think the reassuring story here is that they all tend to be negative, but the point estimates are only significant for a handful of these metrics. So again, back to the story about publication bias, if I'm interested in publishing a paper with significant findings, I might just take one of these results and then publish it in a paper. But in this case, it's just important to think about how those results differ based on the type of metric that you use.
Well, can I ask before?
Yes, please.
With the surveys, how soon after the flood were those done?
Yeah, so in this case, they were done through a general survey that happens every couple of years. So I guess in a way that the timing worked out with this analysis to be able to have a flood in between 2 general household surveys. The survey after the flood occurred about 6 to 9 months after that. So
That might be pretty good.
yeah, the memory would be pretty good, you think? Better than maybe like calling like something like 2 or 3 years. Yeah, that's a good question. Yeah.
I have a question about the maps with the household data.
Yeah.
What are the units on those maps? Are those districts or municipalities or?
Yeah, thanks for the clarification. So this is actually the survey cluster. So essentially like similar to like the local government authority in Nigeria where they have like about 10 households per clusters. So what I would think of this is like kind of like a village, but mostly based upon like the survey administration, how we did the survey.
So there are multiple communities in a single village.
Yeah. Cool. Yes.
Those are DHS data?
So this is like known as the General Gross Household Survey Panel from the LSMS. So the World Bank has like LSMS data in like 8 countries.
So there's
It's one of those.
jitter.
Exactly, yes, and yeah,
The magnitude of the jitter relative to non-correlation between them. How much of a role do you think that geospatial displacement to anonymize the community played?
yeah, so this is a great question. And then just to clarify, what Ron is saying is that. So in this data, we don't have the exact coordinates. To protect privacy, they take the centroid of where all the 10 households are living and take the center point of that location and then take that and then offset that randomly by about 5 to 10 kilometers. So you don't actually know where exactly these households are living. And then when you plot this against different flood maps, something that we're finding is that we run uncertainty analyses. And in case of big flood maps like this, it doesn't really matter because these polygons are so big. So even if they're jittered or not, it's not a big deal. But in the case of data like beers, this data is really high resolution and it's very spectral. So you have like some areas flooded here, some areas flooded here, some areas flooded there. So the larger that you expand your buffer, the more likely that one small speck of the Beers data is gonna land in that 5 kilometer buffer. So you're actually gonna find a higher exposure when you use a data set that's more high resolution and it's more speckled and patterned, because it's more likely to hit some of these larger buffers. So in that case, it really depends on the type of flood data that we use, but it is certainly something that we're trying to figure out how to the best use. Thank you for mentioning that. Yeah, Jen.
Subsistence crops versus crops sold to market, does the survey get into that? Because I'm just wondering, going back to your earlier points on poverty, that the small farmer who primarily grows to feed the family. I'm just wondering if that kind of flood risk loss would be captured in the survey.
Yeah. So the results that I presented here are just on the value of all production, but we did run separate regressions based on the type of crop.
Okay.
And unfortunately, in a lot of these data, people tell you that they have 1 million pounds of certain crops. So we're trying to figure out how to actually use the data in a way that makes sense. But we're finding that it does differ based on the type of crop. We haven't looked at the cash crops or food crops, so it's something to explore. Thanks for the suggestion. Okay, so now I'm gonna fast forward 10 years later to a very similar event that occurred in Nigeria, where the flood was, almost as bad, if not worse. And what are the approaches that we can use using newer technology to try to measure the same flood? And do we get any sort of more congruence, or do we get more confusion? So in 2022, there was a couple of different approaches to measuring this flood. So MDAT is a data set that is run on disaster inventories. And the way that they classify flooding is at the admin 1 level. So in this case, that's really the state level. And according to MDAT, these are the areas affected by flood in 2022. Now we go back to our friend, Dark Flood Observatory. We look at the DFO in 2022, and they show no flooding, which to me was quite shocking. Absolutely no areas of flooding in the entire country for the entire year of 2022. Then, if we use Twitter data, there's a paper here that uses Twitter data. We find that the whole country is flooded based on their classification. So again, a little bit of a mixed bag. But okay, so let's try some other sources. So here is GloFast, which is a new data set that's been able to measure flooding in the last couple of years. And they show a map that maybe seems more believable, where there's flooding here in the south, flooding along the Niger and the Benue rivers, and it's kind of similar to what we've seen before. But this really covers large flood basins a lot better than the smaller flood basins. Okay, so then we use NASA. They have a near real-time 3-day flood product. And the only area that they show flooded the entire season is in this tiny little speck over here. So again, really not sure what's going on. Okay, so all right, so spatial data, fine, things are uncertain. But if we talk to the government, maybe they'll be able to show us better data. So we did. So we talked to 2 government agencies in Nigeria. So one is the National Emergency Management Authority here on the left. And here is the National Hydrological Services on the right. And fortunately, there's a bit more similarity between what the 2 government agencies report as areas being flooded, but they're still really different than from some of the satellite products that I showed to you before. Then we go back to the survey, and the survey data where we asked people whether or not they were affected seems to be a lot more heterogeneous. So, for example, in this area over here, you'll have a lot of people who are not reporting flood in the triangles next to people who are in the squares who are reporting flooding. And I'm going to get a bit more into that in the next couple of slides, but there are all these heterogeneous local impacts that satellite products may not be able to capture. Now, what we do is, let's take some of the more new satellite data that's been put up in the sky over the last couple of years, and try to understand how is some of like the new techie satellite data, what do they show for flooding? And for 4 of these products, for the exact same time period, in the exact same space, we find a very different distribution of flooding overall in 2022. So it seems like 10 years later, despite all of this advance in technology that we've done, all these different ways of measuring flooding from space that we have as a society, I don't know if we're like much better in terms of actually understanding which areas are flooded and which areas are not. But again, more uncertainty in this particular case. Okay, so I only have 20 minutes left, and now I'm going to get into the impact side. So I talked a lot about the exposure, about which areas, which people are actually exposed to flood. Now I'm going to talk about 4 components of understanding how we try to delineate impacts. So what I'll do is I'll first try to figure out, along Bronwyn's question, is how do we take geocoordinates and how do we link them with flood data? The second issue I'll address is how do we integrate multiple sources of information? So how do we take the satellites and how do we take people's responses and try to get a better sense of what's actually happening? I'm going to use the word local a lot because I feel like there's hyper-local impacts to flooding that are really heterogeneous across very small spaces. So talk a little bit about how that's important. And then I'll talk a little bit about why it's important to think about not just the water that's there, but where is the water coming from and what are the causes of some of this volume. We'll see how many of these I get. Okay, so here again, this is a visual that I tried to put in your minds before about how to think about the offset nature of the coordinates with the flood data. So in my data set, I have this coordinate location in the green of a household cluster, and there's about 10 households that are assigned the same GPS coordinate in the cluster. So think of that green dot as representing around 10 households. If I overlay a flood map on it, just without any buffers, I'd probably say it's not flood, because the flood area that's in the blue or in purple doesn't actually hit that particular dot that I'm studying. But because the true location of this household is within 5 kilometers buffer, so within this larger red circle, the larger I buffer, the more likely that this household would be considered flooded in this particular area. So how do we think about this? How do we really understand whether or not this household was flooded? I think these are open questions. I think there's a lot of room for using things like bootstraps, where something that I've done in some previous work is to essentially think of the actual location of the household as being somewhere within this 5 kilometer circle, and basically resample like 10,000 different fake households. So basically, this is like one story where the household could be. Rerun this 10,000 times, where you put the household here, or here, or here, or here, or here, or here, and then run the results and see what the point estimate is of how many times it's in the location and what the standard deviation is. If you find an estimate where it's really it has large standard deviation, then you probably have less confidence in the fact that this house was actually flooded. If you find a pretty tight standard deviation using a bootstrapping technique, then it's probably more confidence that a house was actually flooded. So think about how do we try to approach these cases of uncertainty where we don't have the exact coordinates of the household. The second concept here with understanding impacts is trying to integrate multiple sources of information. And something that we do in our paper for the 2012 flood is to compare or integrate the survey data with the spatial data. So here on the left side, the blue is the spatial data from one of the satellites. And the areas in orange are the households that are considered flooded, and the areas in yellow are the households that are not considered flooded. Here on this side, you have a household who is in a flood area, but is not actually telling people that they're being flooded. So that's what this yellow dot in the flood zone represents. And we compare it to, say, the orange dot in the flood zone. And in this case, the yellow dot in the flood zone is the counterfactual for the orange dot in the flood zone. And what we do is we try to get this using quasi-experimental methods by thinking about this household is a treated household where they're living in the flood zone and are also affected, while their neighbors who are also living in the same general area, but because of the vagaries of how water flows through hills and through different geographies, this household in the yellow did not experience the flood, and they're serving as the counterfactual to try to figure out how do the experiences of this household and this orange dot compared to the household of the yellow dot. So think about how do we create people's responses about whether or not they report a flood with spatial data on what's happening in their general space and the general area for some more quasi-experimental or causal interpretation of the impacts of flood. So that's one approach that we're taking. It's not amazing, but I think that it's trying to get on top of some of these things a bit more. Okay, so then here's the L word, local. And something that we find is that this figure over here is from the household survey data for 2012. And when they asked the community leaders whether or not the community was impacted by flood, they asked them to estimate what proportion of households within your community was actually affected by the flood. So think of this as if the geography department was the big community, you have the leaders, the head department, and then Brian, the other people, think about who in this huge space of geography was actually exposed to a flood. And it might be that everybody is actually exposed to a flood, or it might be that a few people are exposed to a flood. And this actually, we find that there's a large distribution of how many people within a community are actually exposed to the flood. So in certain cases, you'll have almost 90 to 100% of the entire community that's being affected by a flood, or you think that the water is everywhere and everyone's really affected. But you'll also have situations where between 10 and 30% of the population are exposed to a flood. You'll have situations where it's something more like 50-50, where some people are, some people aren't. And this has a lot of interpretations for how do we understand who's actually impacted and who's not impacted from this program. We find the same thing in the household data, where this shows what share of households per geographic cluster report having a harvest failure in 2012. And in a lot of cases, only about 10 to 20% of farmers actually have a harvest failure. That means the other 80-90% don't. So even within the same cluster, there's this wide distribution of experiences of what's happening on the ground. And one reason why I think this is important is what we're finding in our paper on the 2012 floods is that some households actually benefit from being in a flood area. So we're finding that in particular areas where you have this distribution of farmers who are affected and unaffected, the affected farmers lose a lot. They lose like 80% of their crops. But the unaffected farmers in the same area actually benefit. And they report about a 20% increase in their crop value. And we find data that's linked to higher food prices, so there's a supply shock. But because of the vagaries of how water is distributed, I might be okay. But I might be able to sell my harvest at a higher price. So I actually could benefit from flood. So again, flooding impacts are not homogeneous, they're very heterogeneous across space. So think about this as you sort of like think about what the impacts of flooding are. And even within households, you're going to find very different impacts. So in the data in 2012, about 2/3 of the households say that everybody in their family was affected by the flood. But in about 1/3, they only say one household member was affected with flood. So in this case, it's probably a parent who's giving out meals or unable to work, but the rest of the family is okay. You might also find gender impacts of flooding events, where I've seen some papers in the past where the impacts on infant mortality of extreme weather is concentrated amongst girls, but not actually amongst boys. So there's so much going on even within the household. So this is more of a imploring all of y'all to like, don't just focus at the country level, or even the state level, or the household level. But think about like what's going on within the household and what are the dynamics there. And the more local you get, the more granularity you get, and the better we are at capturing some of these impacts of flooding. Okay, so I still have a little bit of time, so I'll talk about causes. And both in 2012 and in 2022 in Nigeria, there was a lot of rain and there was a lot of precipitation. But one of the reasons why there was such extreme impacts is because there were releases of water from large dams. And this is something that we found, through surveys, through newspaper reports, and it's not always talked about, about why certain communities do experience certain flood events. And these are things that we do as humans. So we divert water, we build infrastructure, we release water during flood events. So that's why I kind of don't like the word natural disaster, because I really don't know what a natural disaster is. It's oftentimes a mix of natural factors like rainfall and human decisions to release water or to live in certain locations that leads to some of these impacts. And so this is Jean-Claude Van Damme, so this is Van Damme from Ted Lasso. Basically, long story short, is that these things were built a long time ago, and they're really not equipped for the large amount of rain that falls in a short amount of time. And because of that, engineers have this very difficult decision to release water from overflowing reservoirs to flood communities downstream. And so this is part of a larger research project that Submarine is a part of. And we're trying to understand how dams exacerbate flood vulnerability in Nigeria and across sub-Saharan Africa. And what I'll do is I'll just give an example of some work that we're doing. And here is the Lagdo Dam in Cameroon. So Cameroon is just to the east of Nigeria. This squiggly thing is a reservoir that holds the water during normal conditions. And someone was able to put this image together using Sentinel-1 data, satellite imagery. And I'll just focus in on 2 locations in Nigeria. And here is at the confluence of the Benue and the Niger River. And the areas in the red are those areas that are detected as being flooded. And our hypothesis is the water that's released hundreds of miles away makes its way all the way down the river and really impacts these communities really severely. And oftentimes the flow of water is coming at a super high speed and people don't know it's coming. So hundreds of people die every year. Their entire crops and farmland are destroyed. they experience the most significant and severe impacts from dam releases. So we're trying to capture the spatial patterns of this, but also some of the impacts on people to be able to understand how these human decisions of releasing water from dam impact people downstream. And this is just another image of some more potential dam releases downstream. So something that is a challenge for us as far as team is to identify what is water that's coming from a dam versus what is water that's coming from rain, and how do we causally interpret water that's being released from a dam using satellite images that happen every couple of weeks or even every couple of days, and tell a story that's actually something that we're doing and it's happening on the ground. To illustrate that a little bit more, this is the case of the Farakka barrage in India, and again, a situation where a dam released water, and there seemed to be a lot of impacts in Bangladesh. This is really political, where I was just talking to folks a little bit a couple weeks ago, where the Indian government denies any wrongdoing about like what they've actually done, and like the research I've seen is that they did release water in this barrage and had huge impacts on people in Bangladesh. And people in Bangladesh are really upset about this and are trying to have something done about this. But the Indian government says, oh no, it wasn't us, we didn't do anything. So here again, there's like a use of satellite data that can try to act as a check. Like, did the Indian government actually release water during this event? Like, can we causally attribute what they did to the impacts that are experienced downstream in Bangladesh? Like, these are really important questions, really difficult questions. My colleagues at the bank couldn't say anything about the Indian government's role in the report that they wrote about this particular event, but I'm not constrained by those limitations. So these are really political questions. In the case of Nigeria and Cameroon, again, this is really political, where decisions made in other countries have huge downstream consequences on people living hundreds of miles away in another country, in another jurisdiction, in another area entirely. So again, causes matter, and these things are really fraught with political and diplomatic tensions. So in the last couple of minutes, I'll just have some closing thoughts. So first, I think I've sort of like hammered this point a lot, but I'll hammer it again. Please think critically about how you measure flooding events in the work that you do. Think about what are the causes of the flooding and try to move just beyond precipitation or rainfall. Think about people's entire life force. So think about if they're exposed to a flood today, they were probably exposed to a flood 5, 10 years ago, and maybe they've adapted to it in a certain way, or maybe they haven't. So think about their historical exposure, think about their current exposure, and think about how their future exposure might also change, and how their decision making also changes alongside with that. I encourage folks to do more field work or ask more questions. So we're planning some field work in Nigeria, in dam communities to figure out how they perceive these risks, just to get a better sense of what's going on. Get as local as possible. Local is probably my favorite word in this talk, so please get as local as possible. And I really think this generalizes a lot more than not just flooding, but all types of environmental exposures that we study as geographers, so try to apply this to other concepts as well. My last 2 slides are just an image of a super fancy satellite, and then someone's experience on the ground, where we might think we're capturing this when we use satellite data, but we might not be. So how do we actually better measure the experience of people on the ground? And how do we use technology to be able to help us get there? And then the last slide is just a plug for this really amazing book that I'm reading. It's called Is a River Alive by Margaret McFarland. And this really asks us to understand how to think of water bodies and rivers as living beings that have their own personalities. And if we're better able to understand water and rivers as they operate, we might be able to design ways to better protect both the rivers and the people that rely on them. So try to think about this sort of longer term history of what rivers are, and how we relate them today. So thanks again for your attention. My name is Mook. My email is mook@bsu. I'd love to hear from you. And thanks for your attention.